grounding electrode is not needed for the structure because it is not permanently fixed to the ground, as per National Electrical Code Section 250.32 exception. The chain-link door and steel grate roof do not require grounding because they are not likely to become energized and therefore do not meet the requirements of National Electrical Code Section 250.4 for. An external disconnect switch is not required because the means of disconnection, which is the circuit breaker inside the control panel, is readily apparent and accessible according to National Electrical Code Section 250.33a. It's crucial that the skid is properly bonded to the electrical system using an equipment grounding conductor. Additionally, the chain-link door and steel grate roof should be securely fastened to prevent them from becoming dislodged and making contact with energized equipment. The area should be clearly marked as an electrical equipment location to prevent accidental contact with energized parts. Let's delve deeper into these concepts. Grounding electrodes are typically required for separately derived systems to ensure low impedance path to ground, which facilitates the clearing of ground faults. However, in this specific scenario, the exception in 250.32 applies because the structure is not permanently fixed to the ground. This exception recognizes that if the structure is not in continuous contact with the earth, a grounding electrode would not significantly enhance safety. The purpose of grounding the chain-link door and steel grate roof relates to preventing them from becoming a shock hazard if they were to become energized. National Electrical Code Section 250.4 outlines the conditions under which metal parts must be grounded to minimize the risk of electric shock. However, since the chain-link door and steel grate roof are not likely to become energized, they do not fall under these requirements. It is still good practice to ensure they are mechanically secure to prevent them from accidentally contacting live parts. The requirement for a disconnect switch is governed by National Electrical Code Section 250.33a, which addresses the accessibility and visibility of the disconnecting means. The code mandates that the disconnecting means be readily accessible to ensure that personnel can quickly and safely de-energize the equipment for maintenance or in an emergency. Since the circuit breaker inside the control panel is readily apparent and accessible, it serves as an adequate disconnecting means, and an external disconnect switch is not required. Bonding the skid to the electrical system with an equipment grounding conductor is essential for creating a low impedance path for fault currents. This path allows the circuit breaker to trip quickly, minimizing the duration of a fault and reducing the risk of electrical shock or a fire. The equipment grounding conductor should be sized appropriately based on the overcurrent protection device feeding the circuit. Marking the area as an electrical equipment location serves as a visual warning to personnel, alerting them to the presence of electrical equipment and the potential hazards associated with it. This helps prevent accidental contact with energized parts and promotes a safer working environment. Always consult the latest edition of the National Electrical Code and local amendments for the most accurate and up-to-date information. Remember, electrical safety is paramount, and proper installation and maintenance are crucial for preventing accidents and ensuring the safe operation of electrical equipment. Consider additional safety measures such as using ground fault circuit interrupters or ground fault protection of equipment to further enhance safety in areas where electrical equipment is used. Regularly inspect electrical equipment and wiring to identify and address any potential hazards. Ensure that all personnel working with electrical equipment are properly trained and qualified to perform their tasks safely. Always de-energize electrical equipment before performing any maintenance or repairs, and use appropriate lockout-tagout procedures to prevent accidental energization. By following these guidelines and adhering to the National Electrical Code, you can create a safer working environment and minimize the risk of electrical accidents. Now let's consider some additional details about the equipment grounding conductor. The size of the equipment grounding conductor is typically determined by National Electrical Code Table 250.122, which correlates the size of the overcurrent protection device to the minimum size of the equipment grounding conductor. It's important to select the correct size to ensure that it can effectively carry fault current back to the source. The equipment grounding conductor can be either a wire or a metallic raceway. If using a wire, it should be insulated and identify it with a green color or green with one or more yellow stripes. The equipment grounding conductor should be securely connected to the skid and to the grounding terminal bar in the electrical panel. Ensure that all connections are clean and tight to provide a low impedance path for fault currents. In addition to the equipment grounding conductor, it's also important to ensure that all metal parts of the skid are bonded together. This helps to create an equipotential plane, which minimizes the voltage difference between different metal parts and reduces the risk of electric shock. Bonding can be accomplished by using bonding jumpers, which are short lengths of wire that connect different metal parts together. The bonding jumpers should be sized appropriately based on the size of the equipment grounding conductor. When installing electrical equipment in a hazardous location, such as an area where flammable liquids or gases are present, additional precautions must be taken to prevent explosions or fires. This may include using explosion-proof equipment, sealing conduits, and providing intrinsically safe circuits. Consult the National Electrical Code for specific requirements for hazardous locations. Regularly inspect electrical equipment for signs of damage or deterioration, such as cracked insulation, loose connections, or corroded terminals. Replace any damaged or deteriorated equipment immediately to prevent electrical hazards. Keep electrical equipment clean and dry to prevent insulation breakdown and corrosion. Do not overload electrical circuits, as this can cause overheating and potentially lead to a fire. Use appropriate surge protection devices to protect sensitive electronic equipment from voltage spikes. Educate personnel about electrical safety and the proper use of electrical equipment. Provide regular training to ensure that they are aware of the hazards and how to prevent accidents. Follow all applicable safety regulations and codes. Electrical safety is a shared responsibility, and everyone has a role to play in preventing accidents and ensuring the safe operation of electrical equipment. Let's further explore the requirements for disconnect switches. While an external disconnect switch is not required in this specific scenario, there are situations where it may be necessary or desirable. For example, if the control panel is located in a remote or inaccessible location, an external disconnect switch may be provided for convenience and safety. An external disconnect switch should be clearly labeled to indicate its purpose and the equipment it disconnects. The disconnect switch should be readily accessible and located in a safe location where it can be easily operated in an emergency. The disconnect switch should be rated for the voltage and current of the circuit it disconnects. It should also be suitable for the environment in which it is installed, such as a wet or corrosive location. When selecting a disconnect switch, consider the type of enclosure, the number of poles, and the operating mechanism. Enclosures are available in various materials such as metal, plastic, and fiberglass, and should be selected based on the environment. The number of poles refers to the number of conductors that the switch can disconnect. The operating mechanism can be either manual or automatic. Manual disconnect switches are operated by hand, while automatic disconnect switches are operated by a relay or other control device. Regularly inspect disconnect switches to ensure that they are in good working condition. Check for any signs of damage or deterioration, such as cracked enclosures, loose connections, or corroded terminals. Replace any damaged or deteriorated disconnect switches immediately to prevent electrical hazards. Keep disconnect switches clean and dry to prevent insulation breakdown and corrosion. Ensure that disconnect switches are properly labeled and that personnel are aware of their location and purpose. When performing maintenance or repairs on electrical equipment, always disconnect the power supply at the disconnect switch before beginning work. Use appropriate lockout-tagout procedures to prevent accidental energization. By following these guidelines, you can ensure that disconnect switches are properly installed, maintained, and used to provide a safe and reliable means of disconnecting electrical equipment. It is important to remember that the National Electrical Code is a minimum standard for electrical safety. In some cases, it may be necessary to exceed the requirements of the code to provide a higher level of safety. Always consult with a qualified electrical professional to determine the best approach for your specific situation. They can assess your needs and recommend the appropriate equipment and installation practices to ensure the safety and reliability of your electrical system. Keep in mind that electrical codes and regulations can vary depending on your location. It's important to be familiar with the local codes and regulations that apply to your project. Your local electrical inspector can provide guidance and answer any questions you may have. Regular electrical inspections can help identify potential hazards and ensure that your electrical system is in compliance with the applicable codes and regulations. Schedule regular inspections to maintain a safe and reliable electrical system. Staying informed about electrical safety is an ongoing process. Attend training courses, read industry publications, and participate in online forums to keep up to date on the latest developments. Share your knowledge with others and help promote electrical safety in your community. By working together, we can create a safer environment for everyone. Finally, let's address the importance of proper documentation. Keep accurate records of all electrical work, including drawings, specifications, and test results. This documentation can be invaluable for troubleshooting problems, performing maintenance, and planning future upgrades. Store your electrical documentation in a safe and accessible location where it can be easily retrieved when needed. Regularly update your documentation to reflect any changes or modifications to your electrical system. Proper documentation is an essential part of electrical safety and helps ensure the long-term reliability of your electrical system. In summary, when dealing with a skid-mounted chemical metering pump and chemical storage tank, remember that a grounding electrode is not needed if the structure is not permanently fixed to the ground. The chain-link door and steel grate roof do not require grounding if they are not likely to become energized. An external disconnect switch is not required if the means of disconnection is readily apparent and accessible inside the control panel. However, the skid must be properly bonded to the electrical system using an equipment grounding conductor, and the chain-link door and steel grate roof should be securely fastened. The area should be clearly marked as an electrical equipment location. Always consult the latest edition of the National Electrical Code and local amendments for the most accurate and up-to-date information. Electrical safety is paramount, and proper installation and maintenance are crucial for preventing accidents and ensuring the safe operation of electrical equipment. Let's elaborate on the significance of bonding in electrical systems. Bonding is the process of connecting all non-current carrying metal parts of an electrical system together to create a low impedance path for fault currents. This low impedance path allows the circuit breaker or fuse to quickly trip, interrupting the flow of current and preventing electrical shock or fire. Bonding is essential for electrical safety and is required by the National Electrical Code in most situations. The equipment grounding conductor is a critical component of the bonding system. It provides a direct path for fault currents back to the source, allowing the overcurrent protection device to operate quickly. The equipment grounding conductor must be properly sized and installed to ensure that it can effectively carry fault current. In addition to the equipment grounding conductor, bonding jumpers are used to connect different metal parts together. Bonding jumpers are typically short lengths of wire that are connected to metal enclosures, raceways, and other metal parts. The bonding jumpers must be sized appropriately based on the size of the equipment grounding conductor. Proper bonding helps to minimize the voltage difference between different metal parts, reducing the risk of electric shock. It also helps to prevent the buildup of static electricity, which can be a hazard in certain environments. Regularly inspect bonding connections to ensure that they are tight and free from corrosion. Loose or corroded connections can increase the impedance of the bonding path, reducing its effectiveness. Repair or replace any damaged or deteriorated bonding connections immediately. Bonding is a critical aspect of electrical safety and should be performed by a qualified electrical professional. Now, let's discuss the importance of ground fault circuit interrupters, often referred to as GFCIs. Ground fault circuit interrupters are life-saving devices that protect people from electric shock. They work by monitoring the current flowing in a circuit and detecting any imbalance between the hot and neutral conductors. If an imbalance is detected, the GFCI quickly trips, interrupting the flow of current and preventing electric shock. Ground fault circuit interrupters are required by the National Electrical Code in certain locations, such as bathrooms, kitchens, and outdoor areas. They are also recommended for use in other locations where there is a risk of electric shock. Ground fault circuit interrupters are available in two main types: receptacle type and circuit breaker type. Receptacle type GFCIs are installed in place of standard electrical outlets. Circuit breaker type GFCIs are installed in the electrical panel and protect the entire circuit. Regularly test GFCIs to ensure that they are functioning properly. Test them monthly by pressing the test button on the device. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. Ground fault circuit interrupters are an essential safety device and should be used in all locations where there is a risk of electric shock. Let's consider the topic of surge protection. Surge protection devices, or SPDs, protect electrical equipment from voltage spikes caused by lightning, power surges, and other electrical disturbances. Voltage spikes can damage or destroy sensitive electronic equipment such as computers, televisions, and appliances. Surge protection devices work by diverting excess voltage away from the protected equipment. They typically contain metal oxide varistors, or MOVs, which are devices that change their resistance based on the voltage applied to them. When a voltage spike occurs, the MOV quickly reduces its resistance, diverting the excess voltage to ground. Surge protection devices are available in various types, including whole-house surge protectors, point-of-use surge protectors, and plug-in surge protectors. Whole-house surge protectors are installed at the main electrical panel and protect the entire electrical system. Point-of-use surge protectors are installed at individual outlets and protect specific equipment. Plug-in surge protectors are plugged into an outlet and provide surge protection for the equipment plugged into them. When selecting a surge protection device, consider the surge current rating, the voltage protection rating, and the clamping voltage. The surge current rating is the maximum amount of current that the device can handle. The voltage protection rating is the maximum voltage that the device will allow to pass through to the protected equipment. The clamping voltage is the voltage at which the device begins to divert excess voltage to ground. Install surge protection devices properly according to the manufacturer's instructions. Regularly inspect surge protection devices to ensure that they are functioning properly. Replace surge protection devices if they have been damaged or have absorbed multiple voltage spikes. Surge protection devices are an important investment in protecting your valuable electronic equipment. Proper lockout-tagout procedures are crucial for electrical safety during maintenance and repair work. Lockout-tagout is a safety procedure that ensures that electrical equipment is de-energized and cannot be accidentally energized while work is being performed. The procedure involves locking out the power source to the equipment and tagging the lockout device to warn others not to energize the equipment. Before beginning any electrical work, identify all potential sources of energy to the equipment. This may include electrical power, hydraulic pressure, pneumatic pressure, and stored energy. Disconnect all sources of energy to the equipment. Use lockout devices to prevent the energy sources from being re-energized. Lockout devices can include padlocks, tags, and other devices that physically prevent the energy source from being turned on. Tag the lockout devices to warn others not to energize the equipment. The tag should include the name of the person performing the work, the date, and the reason for the lockout. Verify that the equipment is de-energized before beginning work. Use a voltmeter or other testing device to confirm that there is no voltage present. Perform the maintenance or repair work. Once the work is complete, remove the lockout-tagout devices. Ensure that all personnel are clear of the equipment before re-energizing it. Lockout-tagout procedures are essential for preventing electrical accidents and injuries. Let's talk about electrical safety training. Electrical safety training is essential for anyone who works with or around electrical equipment. The training should cover the hazards of electricity, safe work practices, and the use of personal protective equipment. Electrical safety training should be provided by a qualified instructor and should be tailored to the specific tasks and equipment that the employee will be working with. The training should cover topics such as electrical shock, arc flash, electrocution, and electrical fires. Employees should be taught how to identify electrical hazards and how to avoid them. They should also be taught how to use personal protective equipment, such as gloves, safety glasses, and insulated tools. Regular refresher training should be provided to ensure that employees are up to date on the latest safety practices. Electrical safety training is an investment in the safety of your employees and can help prevent accidents and injuries. Now, we should consider arc flash protection. Arc flash is a dangerous phenomenon that can occur when electrical equipment is energized. An arc flash is a sudden release of electrical energy that can cause severe burns, blindness, and even death. Arc flash can occur when there is a short circuit or other fault in an electrical system. The intense heat and energy released by an arc flash can vaporize metal, ignite flammable materials, and create a pressure wave that can throw people across a room. Arc flash protection is essential for protecting workers who may be exposed to arc flash hazards. Arc flash protection typically involves the use of arc-rated clothing, such as shirts, pants, and jackets, as well as other personal protective equipment, such as face shields, gloves, and hard hats. Arc flash clothing is designed to resist the heat and flames of an arc flash and can help to protect workers from serious injury. Arc flash studies are conducted to determine the potential arc flash hazards in a particular electrical system. The results of the arc flash study are used to determine the appropriate arc flash protection requirements. Arc flash protection is a critical aspect of electrical safety and should be implemented in all areas where there is a risk of arc flash. Finally, let's discuss the importance of regular electrical inspections. Regular electrical inspections are essential for maintaining a safe and reliable electrical system. Electrical inspections can help identify potential hazards such as frayed wires, loose connections, and overloaded circuits. The inspection should be performed by a qualified electrical inspector who is familiar with the National Electrical Code and local regulations. The electrical inspector will conduct a visual inspection of the electrical system and will also perform tests to ensure that the system is functioning properly. The inspector will provide a report of any deficiencies that are found and will recommend corrective actions. Regular electrical inspections can help prevent electrical fires, electrical shocks, and other electrical hazards. Schedule regular electrical inspections to ensure the safety and reliability of your electrical system.